All right, we're going to start with the next session. This is load transfers at sea by Amber and Paul.
I just want to introduce myself. I'm Paul Walczak. I'm giving this talk as a MarSSAM person. I was asked to do it a long time ago. I'm transitioning away from MarSSAM now. It's, they plan our VTech way out. And I actually don't quite remember how I got put together with Amber, but I was like, great. Somebody else is doing presentations, so I have more than one slide. And Amber's relatively new, and I can let Amber introduce herself. But before I leave that, I think one of my values to everybody in the room that's young is there maybe is nobody at the time that has lost or destroyed more stuff that Steve and I have. As instant coring loves to lose and destroy things. And I've seen a lot of really weird things. It's sort of one of the natures of instant coring. Things go non-linear. So feel like, oh, I'm doing this really kind of weird thing, go ahead and try and track me down. All the tech managers know.
Yeah.
Okay, yeah, so that's a little bit about Paul. Paul's with MarSSAM. Why are Paul and I friends? I'm Amber. I'm a resident technician at Scripps, or Res Tech for short. Scripps, we do our technicians a little bit different than everyone else in UNOLS. So we have Res Techs who run the deck. It's basically like a bosun for most of the other people in the UNOLS fleet. We run all the overboarding operations as well as do the liaison work between the science party before coming on board. And then we have instrumentation techs that help out more inside with our instrumentation and underway systems. So similar to Paul, when I'm on the ship, I'm usually running the deployments on deck. I'm usually outside most of the time. And so because of that, I see a lot of tension transfers on deck. We go on a cruise by cruise basis. I don't stick with one ship. So whether it's the Sally Ride, the Ravel, or the Sproul, whatever science wants to be done, I'm gonna help them do it. And so because of that, I've seen a lot of things get transferred under tension. So we're going to talk about that today because it's important across the UNOLS fleet and not everyone gets a hand on deck. But the biggest thing I want you to take from today is these are all tools for you to use in the field. Nothing is an end all be all here. This is just trying to show you how to find your resources when you get out on deck and you're trying to figure out how do I get this really heavy thing from this line to this line. So yeah, what are load transfers? It's taking a line under tension and moving it to a different point under tension. We see them all over UNOLS, a lot in coring with Paul, but not only that, we see them in moorings, seismic surveys, magnetometer tows, and imperfect instrumentation recoveries, aka screw-ups. Not everything goes to plan when we're at sea. We really hope it does, but the ocean has more strength than we do, so we roll with what we get.
You want to talk about any of those pictures? One.
Okay, so for some of these, the top picture is a floating array actually going off of the Ravel earlier this year. We do tension transfers for these light moorings. Whenever you're taking them on and off the ship, these have bottles that if you're in rough seas, maybe you're securing it off to a cleat so you can put these bottles in without the X-ray getting snapped out of your hands. One thing to note for this top mooring photo too, you'll see that we're utilizing a hanging block or traveling block for this floating array recovery or deployment. One thing to note when we're the little guy hanging up there with the two lines. When you're using a traveling block, make sure that you know what your tension is going through that block, because you essentially have two blocks at that point holding the pressure or that tension that is going through the block. So you not only have the tension of that line, but what the top line is holding also. So it's really important before you do any of this to know your weights. That should be your number one thing when you're moving. What are these heavy things? How much do they weigh? If you don't need to know it now with a crane pick, you'll probably need to know for ballast or overboarding later on. So really know what the weight of your items are, know what the safe working loads of your winches and your cranes are on deck before you do anything. Really check where those tensions are running and what your original line is and where it's going to move to before you make that move. Just situational awareness, think ahead of time. A lot of times when we're doing these load transfers, it might be from a winch. You might not be all the way paid out on that winch, or you might be trying to stop off a winch to add something else, maybe a mooring, maybe you're done with your magnetometer tow and you're ready to tow it off the deck. You actually can't tow a magnetometer from that winch. That winch is not a towing winch. It's not made for that. So you have to create a tension transfer to either have it tow from a deck cleat or some other tow point because your winch is not made for that. So we can add a Yale grip in situ. If you're using the same magnetometer that doesn't have a level wind and you're going at the same point every time, you can actually leave your Yale grip on there for your tension transfer. You're towing at the same point every time. That's awesome. Same goes for seismic stuff. But Yale grips are also really great. They are short-term grips. It's our first grip, temporary. You can use it on synthetics and cables and wire. You can use it for anything. There's a bunch of different types of Yale grips. And anytime you're using any of these grips, there's different sizes. So with Yale, you can see here we have all the material sizes, and then it corresponds to a color actually. So if you're doing 7/16, you're going to use red. So if you have a 7/16 line on board, it's a pretty good idea to have at least 2 of these, maybe 4 of these. They're pretty cheap on board. So if you ever have something go overboard and you need to get them back, you can one by one attach a Yale grip, pull on it, attach a Yale grip, pull on it, and you can slowly recover that piece of equipment. This chart is not only for Yale grips. We also have guide grips on the other side. These are more permanent. After you use it though, you can't use it again, or you probably shouldn't. We use these for a lot of our mechanical terminations. We use it on our CTD. We use it for Machnis on 680. It's another one that's really easy to slap on really fast, but once you use it, probably won't use it again. It's not as good for imperfect instrumentation recoveries. Usually that is part of a system that you're using, whether it's CTD, whether it's overboarding, but that is another type of grip for you to utilize, also really cheap. So if it's something that you have on board, you need to make a point really fast, you can wrap one of those on. And then we also have Klein grips. These are really good for big pulls. They're also reusable. You can use these on big crane whips or big trawl whips. Did you want to say anything about the Klein grips?
I think of these 3 items, the Klein grip is probably the scariest. They're fast. They can maybe be a little slippery when wet. They may not have the right size, but if you're doing, say your take-up drum goes out and you've got a CTD out, and you're having a boom up with the crane to pull it back, the Kleins are super fast. Way faster than all of the other ones. But you may not have them. Not a lot of people carry these anymore. I've never seen one.
We just bought a bunch of brand new ones because we didn't have any of the right size.
Look at it.
9/16 cost like $900.
These lines are used, I think, a lot by like power companies. Power, when the tree falls on a power line, they stick one of those things on, haul over the truck. That's how they.
That's where those guide grips came from too. You see, now you start looking at power lines and things like that, you'll see some of these tools that we use and see. Yeah, they work great.
You guys have any questions on grips? I have made my own grips because we did not have them by chopping the existing whatever line it was off, de-stranding it and re-stranding it, which sucks. But, you know, that work.
Don't do that.
It's recommended. The other thing is this Yale, usually that they want to be, all of these devices really want to pull on them. And one of the things that we all end up doing is like we tape it so it doesn't lose that pull and slack. That's one of the things that, you know, generally they're not fighting with the power line industry is either. So be aware that they want to be pulled. It's not always something that we can keep constant tension on something. So just keep in mind that if it slips, it could just, so definitely start doing this stuff. You're opening yourself up to a slip. And things get a run on you, then that's bad.
But one good thing to do is whatever cables, wires, lines you have on board, you should get a few heel grips in those sizes and keep them on board. Just in case for anything, if you need to tie something off, if you need to recover it, is really handy to have. And they're pretty cheap, so that's good. Don't let scientists steal them from me though. So going with those grips, you need something to grip onto essentially. So here we have our load bearing and our toe points. I don't have all the Glosson diagrams up here of different toe points and things that we use, but essentially when you're considering these points or what you want to tow from, you need to figure out what it means to tow from that point. Not everything is rated equally. If you were here with Aaron's talk earlier, we talked about how to check your deck plugs. Not all deck plugs are made equally. All of this is based on a 2x2 bolt pattern for the Unil ships. This is a deck cleat that has a dual bolt. And if you can actually see from down here, when we're at 90 and tow from the side is when we have our greatest strength here. It's about 2,000, maybe like 1,300 more than when we're towing or cleated off absolute zero, going straight. Same with your eye bolts. You actually have your greatest strength going straight up at 90. If we use eye bolts for pull tests, we're under the A-frame directly up. And that's how you can get some of your greatest strengths. You can do 2 back to back with a sling through it. Make sure that if you're incorporating slings into any of these tension transfers or anything, you're checking the slings, not only for the load of the sling, but also for their basket capacities, their choking capacities, and their loop capacities. There's 3 different weights or tensions for each sling and what they can use. So these are just a few points that you can tow from. There's also H-bits, D-plates, D-rings. D-plates and D-rings are not the same. D-plates are really good for pull test. They're strong. D-rings are more for towing. So if you're gonna do like a seismic tow or something, not necessarily seismic, but D-rings are more of what you would tow off the back of your ship.
Yeah, where do you find lost that?
You emailed the magical Aaron Davis for your specific deck hardware that you have. My deck bolt or my cleats are not going to be the same cleats as yours. They might have a slightly different fabrication, so your loads are going to be different. So every deck component that you're using to pull on something or have a load transfer on, you need to get it approved or get a diagram of that. You need to know how heavy that's going to be the same way. You need to know how heavy is this piece that I'm moving on board right now? How heavy is that piece of equipment I want to put in the water? Is that going to break something off my A-frame? Is that going to break my winch? Is that going to break my line? These are all things to consider whenever you're doing these tension transfers.
Easier to get when you have it manufactured or buy it manufactured. Same as Aaron was saying for your witches and stuff.
Don't take them from your friends unless they have a Glosson diagram. Otherwise,
Glosson will charge you to make
Yeah.
a diagram for anything. Just costs you money. Just buy it.
All right, so coring load transfers. Who knows what a piston core is? All right, so we're pretty good. What makes piston coring unique among, I think, just about all oceanographic devices is it is designed to free fall, which is absolutely crazy, right? Like, you're like, oh, 5,000 pound weight, it can free fall. Now it's supposed to free fall when it hits the bottom. We're going to talk about that a little bit. It's not necessarily always what happens. So there are multiple load transfers that happen with piston coring because you need to be able to accommodate and allow for the free fall somewhere in it. So this is an acoustic release. So you've got your main trawl or synthetic or whatever it is, rope. I think that's a height going to that big shackle at the top of the release. This here is the free fall. This was in super deep water. The huge weight, that's 5,000 pound solid 4 lead weight, so it's not reducible weight, actually stretches the AMS field. or sorry, the height. And so we had to allow for that stretch in the recoil. So if this thing, this slack line here was like 140 feet. So this has the potential, if it was to release in the water column, for that 5,000 pound weight to fall 140 feet before it's caught. Which you really don't want to have happen, but that is a free fall potential that could happen if you mess up your rig. With the acoustic releases, they're generally pretty much locked off state. This is a hydrostatic pin, jams in, the jaw can't open it, in theory, to 100 meters or whatever that release is for. The triggering arm, these are the same action of lifting and releasing. The triggering arm is the mechanical, acoustic release is the electrical way to fire a core off. They both have their benefits. The acoustic release is nice because it's really pretty solid and it doesn't do weird things during heave. Problem is, ship is heaving, so you get to the bottom, you don't know where it's going to necessarily fire in the swell cycle. The arm is always going to fire at about the same spot, but it's subject to heave problems. And you can see that there's this pile of extra rope. That is a load transfer that has to happen upon recovery. This is basically just lifting like a gravity cord up and out. Like that's one lift on deployment. If you hit this arm, which gets a load transfer of that weight onto the arm to engage it, if you're doing a launch, which ends up in this position, and as you A-frame out, you hang that arm up, say on that platform, the whole thing could go and just fire right at the surface. That would be bad. So this loop is what allows it to free fall. So that's a launch sequence. Various vessels. This is the way that they've been doing it since like the 30s. This is more modern. So a bunch of different ships, happens everywhere. And I guess we can go to the next picture. So this is just more clear pictures of it because this is key. So again, you can see it's in launch mode. It's getting ready to go out. And one of the rigging problems that we have is when it comes back, you've got that. And obviously you can't suck this thing up through your block to recover it. And so you've got to get this out of the way and get that line on something else so you can get it all back and handling stuff. Yeah, and then you've got to recover this one also. So you start with that one, then you get rid of that. So it's a multi-step process, takes a long time. And we do it every deployment. So I've done a lot of load transfers. Go to the next one. So this is recovery, same, two different items. This is something that Amber and I also wanted to talk about right here. I know it's hard to see. This is a load transfer where we're using a soft shackle. How many of you guys have used soft shackles? Soft shackles are pretty awesome. They're made of plasma, and it's basically a shackle. But what's really cool is they're strong. They don't have pins. They float. Kind of hard to recover if you drop them. And you can actually make them yourself in different customizable lengths. So if you find yourself, man, I really wish I could use a shackle right here. Instead of swinging a shackle, you could soft shackle it. So this one, what you're seeing here is you're trying to get the weight off the main trawl so that you can actually recover the quarter. Same thing's happening here, it's just different. I will note this one here is a strap that is onto a pin, and we are struggling to get that soft shackle through because it's got 5,000 pounds on this little bead. Like crowbarring it to get it open. This one is a more modern one where it's actually a bunny ear splice. So it's a one long piece of stand steel, and it actually has a long splice going into it. So it's made two bunny ears with individual loops. That really helps, but it's a custom piece of rigging that you really want to think about that in advance. Let's move to the next slide. Again, this is just trying to get that soft shackle because this pin is holding all of that weight on a load transfer. So it's just a bit more picture of it. This is the winch that we're transferring the load to. And then it's actually a double block. And so we've got the load of the core head here, and then the load of the reliefs on there. That line is going up and into the ship's winch. This line is going down with this portable winch here. We're getting things off of the ship's winch onto portable winches so we can recover on the ship. You guys all following this? Still trying to get the pin out. Keep going. Okay, so now we've got everything. The weight is back in the bucket. This line is slack. That's the internal pendant line. And this is like, all right, we've got things basically secure in buckets on deck. We can take a breather, chill out. Like, and I would suggest when you get things a little bit like into a stable spot, kind of do a bit of cleanup just so you don't get line confused. I have gotten line confused bad. So yeah, you just like one of the things I think was Heather's picture too is you get all of these lines going the way that it can be sometimes be a bit much. Got next. Here we go.
Okay, so this is back to kind of what I was talking a bit earlier. This is a seismic setup actually that we just had on the Ravel. You can see, as I was talking about, we have that sideways facing cleat, because I showed you guys my diagram before. We get a little extra strength when our cleat's at 90. This is an example of a D-ring load. Once again, you see this is 0, just straight off the deck, and that's where we have our strongest capacity there. Aaron was kind of talking in Appendix B earlier about how we try to pull on these things from all different directions to try to see what our line is doing and the best tension transfers. It's to make these diagrams so that when these lines are tending off the deck, when your hands are next to these lines, you can feel better, essentially, that these things are going to have your back and going to help you keep all your fingers while you're working on this stuff. So actually in this seismic setup too, I don't know if you can tell, but that's actually a Yale grip right there that we were using on a secondary cleat to tie off. So we have 2 lines going for our deployment line, and then our strength member that goes out with our umbilical. The strength member is what we tow off of on our cleat here. So whenever we're getting to that final point, we've gotten to the length of our umbilical that we want to pay out. That is when we would essentially tie off with one cleat and just piece the line, and just get tag line, whatever we got on deck. As long as you know your tag line is good for these strengths, and then just cleat off, quick slip back to the umbilical line, and then this is what's towing for you while we did 24 hours of seismic work. Ignore the bungees. They were trying to reduce strumming of the line. It's seismic. I don't really, whatever. But anyways, this is a Yale grip. This is one tension transfer that we would do essentially to save everyone's fingers when we're setting these lines, setting these long tow points. Then you can set it and forget it. This is pretty similar to what we would do on a magnetometer survey too, if you're using small winches with the tow body. That's really great. And once again, if you're using winches that don't have a level wind on it, if you have a level wind on it, your Yale grip will not fit through. So you will have to take it on and off, but leave a piece of tape. You can either start your Yale or end your Yale at the same tape, and then you essentially get the same tow line every time anyways. So mooring load transfers. This is kind of one of the ending pieces, but really quickly, moorings get crazy really fast. There is at least 3 winches, 4 winches involved here. We got 2 air winches, air tuggers right here. Got a Hubble winch. Got 2 different block setups. This one's on a pulley system. This one's just on another airlock, and all this other stuff that's going to get on this line. So moorings are nothing but tension transfers. The entire time we're doing these, we're trying to get ourselves in the best position to add the next piece of instrumentation to the line. Usually we're not doing grips with this. It's more through the shackles and the paralinks and the jewelry that's on the mooring to set up a line, do a tension transfer. Your line's safe for you to go touch, everyone backs off, you release and keep going out. Big ones that can be scary ones are when you're doing your final or maybe beginning part of your mooring with your big weight. Going weight first on a mooring sucks, but sometimes you have to do it. And at the end, or if you're doing the weight at the end, and then you get to just like pelican hook it and watch it all come down, that's really fun, but that is also a load transfer. You're still transferring the load from the ship off. There are a few different ways to do that, whether you're gonna pelican hook it, you can knife it, but if you're gonna knife it, do it right. We kind of talked about that already.
Does anybody do small boat moorings here in this room? I will say that if you're trying to do a load transfer I had the last really scary thing I did, and it was totally stupid. Maybe we can back this. So one thing I will tell you guys, we intentionally did not make an hour-long talk so that we could have people discussing things in the talk. But if we go back a couple slides, piston pouring, I had maybe one more. I had one of these come up, totally wrapped. So this line got wrapped around that line. This sort of thing just happens, right? So this got really hung up. So it made that load transfer really, really difficult. And
This one. You can kind of see it's wrapped up.
oh, this is a different one. That's a different kind of wrap up. But anyway, it makes the load transfer really, really, really difficult. I think Chris was in there. Got the captain out, had the bosun out. We were all standing around. Of course, it was the last pour of the trip. Of course, there was a hurricane coming. Of course, it was a 3-hour evolution that took 5. And we're sitting there just going, oh shit, like what are we gonna do? And with super high tensions, we couldn't undo it, and we're just cut it. So I thought that rope, in this particular occasion, was polypro with over 1,000. It was actually, as it turns out, I think it was holding up the core weight. Had tremendous force on it, and it just blew up, and it just like, oh, lesson there. If you're gonna get to the point where you have to cut stuff, take your knife and tape it to a bowl. Like seriously, like I know that sounds totally hillbilly, but like get your knife, put it on a boat hook, stand back. Like it's just sometimes that's like what you gotta do. But like you don't want to get there, but it ended up being, the discussion between the captain of those and myself, Chris. It was like, this is the safest thing to do. Is just bail on that piece of equipment. We literally like couldn't think of a better way to get it back. And I should have known better, but I didn't. So that's something I really wanted to talk about, because I've also done moorings from smaller boats, not in the academic research fleet, where you kind of don't have a lot of tools, and you just put a weight in and you tie it off and you flake out your chain and then you stand back in. Okay. Also, probably, I don't know if that's recommended and anybody does it anymore, but that is something that has happened in the past and probably so
It's how the Coast Guard sets navigational beliefs.
Yeah.
Chain gets faked out on that. And guy with a sledgehammer, it's the trip.
Oh, yeah, there you go.
So we don't do a lot of moorings on the can because we can't cover them. The frame is too short. We deploy it here. Maybe it's the watch mooring. So when I saw them do, this is a giant mooring by any means, but they had a load transfer and they let, the weight is last, they let the chain out easy so that the whole array is now pulling on the weight that's on a skid plate, pre-positioned on the very back, edge of the ship essentially. And we just sit there and sprayed it with a hose and kind of kicked it and it just fell off.
So that would be an anchor last deployment versus
Yeah.
anchor first deployment. It seems like the people that I've seen do it really want to be like, okay, we're gonna get a ship right here, let the anchor rip, so it's at that point. If you're doing your array first, maybe it's a little harder.
I think the theory behind just kind of nudging it off like typically was nobody wanted to figure out how to actually lift it, release it, and not see the release shoot into the air back in someone's face or something. Fine.
And those ones that I've seen and experienced, those have all been relatively shallow. You got any other questions? Anything anybody wants to talk about? Anything?
Can I ask a quick question? So it's obviously been a long time since I've done this, but back in my day, we used to draw it all out. Where you're gonna hook into, where you're gonna add your nail grips. Is that still a thing, or is there a better way of doing it?
Are you talking like for moorings or which deployments?
For
Just
for load
anything.
transfer, where you're gonna grab from,
Yeah, what do
I
you
guess
grab?
most moorings. Where you're gonna stop, where you're gonna hook on, where you're gonna release. You used to just sort of draw it all out.
In the boring diagrams, what I've seen.
Yeah.
recently.
On MFP, we always have our science parties upload the mooring diagrams, and then we'll either talk through piece by piece with them how they want to go through it. Sometimes there's like if it's OOI's special mooring groups coming on, we work with them on the deck and they know their systems. But we go through before and have a talk through. I mean, before I run any deck operation, I have a deck meeting. We establish everyone knows what they're doing, knows what their job is for the entirety of the operation, what that entails and how long they have to stand there, and then we'll proceed.
Yeah, that morning diagram is very detailed. And
Yeah.
Yeah.
Shackle, parallel, shackle here. instrument here.
It's good to be annoying about diagrams.
I used to work for the Global Tropical Mooring Buoy Array, and we deployed hundreds of moorings a year, and we worked really closely to make sure that we would know where those load transfer points are. We talked it through with the crew and the deck people, just to make sure everyone was on the same page ahead of time. So of course, it doesn't always work out how you want it to, but for the most part, I do think those mooring diagrams are really important for picking your transfer.
If you ever see one where they're like, we're deploying it, so we just have a shackle into a termination, and a paralink, always have shackle, paralink, shackle, so we're in both directions. Sometimes they are designed to deploy and they're like, oh, we gotta recover. And it's much harder to get into a shackle.
And I would definitely,
Maybe some experience.
as a technician working on a research ship, I think that if you are dealing with an OOI mooring, like you're dealing with something that is professionally made, right? Like it's thought about strongly. And most of the stuff that the globals are going to be doing is probably coming with like a pretty good mooring diagram, a pretty good plan, probably components that are made of pretty good materials. Whereas if you're doing some science party mooring thing where they had a budget of $300 to make their buoy that's been out for a year and a half, and just in the mud and all this crap, and they're like, oh, I'm gonna use this nice stainless steel shackle so it doesn't rust, and you're bringing this stuff back. This is, I think, one thing that you really have to keep in mind is they can be very little, but like a very little 300-pound anchor is still gonna kill you. So be really careful because those shackles can rot. Like this stuff, like you gotta really know that if it lets go, like you don't want to be in a bad spot. And like, where's safe right here? If you notice that I had all those pictures of piston port, and one of the things I spent a lot of time doing is like just standing around with it. And that's also for stuff too, because you just want to make sure that nobody's doing something in a really bad spot. Because these things can just like go, and you just don't know.
I think it's good to know how to make a loop in a line that's under tension. Kind of sounds funny, but like, when I was really new, I had this trace metal array to recover that was built by like a fresh student that, just got their bachelor's or something. Never really done any of it before. And they didn't put the load transfer points close enough to each other. So we're recovering it, and the thing gets to like the block.
Yeah,
you know where to grab.
it's down.
Yeah, it's like in the water still.
Yeah.
And so we're looking at it like, what am I gonna do now? It's not super heavy, but like at that moment, I just didn't have a lot of like, here's how to put a loop in the middle of this line while it's still being towed behind the ship. What do you do? How do you make some taut line off to a cleat somewhere and deal with it?
How do you get some tension in something that's humming?
Yeah.
Or like some slack in something that's humming.
Gain and swell.
Also, if you do ever stop off a load, make like it's something that's not particularly heavy, you just need to tie like an alpine butterfly in the middle of the line or something for a pick point. Don't use the method where you're wrapping it around. There's two ways to tie an alpine butterfly. It's one where like you wrap it around your hand. Sometimes that happens with like your tension tie off goes. There's another way to do it. Maybe learn that.
So should we move on to our blooper
How do
slide?
you get a loop?
Yeah.
This
This is basically our blooper slide, our imperfect instrumentation recoveries. I think that probably some of you guys heard Ethan talking about the LARS systems where they were kind of eating instrumentation for a bit. This is us getting back our CTD. It didn't actually go overboard, but it saw a lot of tension. This is at least 14,000 pounds of tension. You can see our guide grip is hanging on by a thread, but it saved us and she's still there. If that ever happens to you, do not suck your CTD back into the LARS system. Like if you're already out of the auto docking, it might sound whatever, but there's jibs and there's booms on these LARS systems. If you jib or boom incorrectly, you are going to increase the pressure on this system when it's already under pressure. Stop. Number one, hook in to your CTD. Get a line on it. And then you want to have your CTD still hanging from the LARS system. You don't want it to come back up and have connection to this base plate because that's when you can have tension shifts further as you're bringing it. And that our arm is a finger essentially where it jibs out, booms out, extends out. And so you have to do all of that in reverse to come back on board. And you have to think about how those tensions are going to change as it's coming back. We got it, yay. This one, Paul kind of talked about it, having loops in different instrumentation as you recover it. If you've ever had a Machnis flip on you, hopefully it doesn't, but they helix and they'll fly crazy. And then you have to recover it after it's been super spun up and you have this crazy loop in your cable. How are you gonna get that out? Hopefully it's not the 10 meter, hopefully it's just the 1 meter. This is an example of a Yale drop being used on a wire in port. And then this is 2,000 pounds of tuna crabs that was so heavy that we had to do a tension transfer thing to get this back on board. So that's awesome. Yay. Does anyone have any fun recovery stories to share of tensions or anything, truly?
All of us at one point, on a small boat, one thing we had was a polyester, made a pendant on the A-frame, polyester to it, the polyester to the line, and we just like use it as a nipple, it's like A-frame, not A-frame. We finally got.
That would be like one of those things you squeeze into your hand and slip it.
Well, yeah, that's the big frame. Yeah. You tie your line to it, so then you fall.
One other thing that this is a little bit out of order. Talk about end-to-end splices. Now this is an end-to-end splice in like a 3-strand, but for demonstration purposes, I think it makes it a little bit easier to visualize. Why I want to talk about this is I've heard rumors of doing large mooring recoveries on the RCRBs, which may come provided with plasma HICO line on them. One of the possible ways to do a recovery efficiently on those boats is to bring the mooring up, line through the standard, A-frame block system, bring the trawl rope out of the winch room, meet the two on deck, and do a long splice to join them, and then go ahead and just haul the thing back onto the ship's main pickup drum, all the way through the block system and the traction unit, in order to do a cleaner, less deck space intensive, which I think is actually pretty doable. You can do a long splice in hollow core pretty fast. I was on the Odin on the Peterman trip that Larry talked about yesterday, and how many of you guys have actually used HICO and steel blue as a working line on a winch? So when you're in deep sea, what happened, it's actually, I think Chris was there, we were multi-coring in the Puerto Rico trip. And we got like 6,000 meters out, and the thing was just floating, hanging out at 60 meters a minute, 40 meters a minute, and the line's just like down to the deck, up over the water. Like, no tension on it because everything's just like kind of floating. It's just super weird. But in that situation, we're all panicked. You're jump the block, and that plastic rope just hit micro small. It's just in, it's like on your block, like on the tin of the block, and then you're like, oh shit, that's not everything, right? And then it's jammed in there, and so the thing to do is just A-frame in, get some slack, stop her off and pay out, stop her off the other end, cut it, and splice it back together. We did that on the Odin, and it worked, and we just kept working on that line, and who knows, probably still the same one.
Given how labor intensive is the splicing, then how long of a splice did you do? Because there are standards on this for mooring ropes and people to overlap each side, like how much of a split did you do?
I want to be perfectly clear. I don't do moorings. I have talked a lot with Alex Wick, who I think came up earlier. He's OOI from OSU. He's done quite a bit of testing on splicing because they are running at the ragged edge of what we can do besides the and it's the heat that's killing us, right? Like the mooring itself is not too heavy, but you start getting that drag and your tension numbers go crazy. And there is a reason that manufacturers recommend 5-to-1 on this stuff, but we can't because it's just too strong and destroy, like our A-frames can't do it. So he's done experimenting. I've done some experimenting. I've called, somebody was asking about Fort Williams number. I've had really great conversations with those guys. When you do a splice, and it's really pretty easy to splice this up, you have to do it right. Because if you cut off your rope at the diameter and you do not do your end, it will pop like at like nothing. Crazy how doing a proper tapered splice in that stuff really ramps up your strength. Then you got to start thinking about like what kind of eye, all this stuff. And I think Rick has talked about that for Trask in the past, about like proper eyes to use. I highly recommend beach fittings in wire. It appears that the company is now making them for synthetics. I have not seen one myself. I got information on it from Acme people. I think it's coming. My experimentation with those in the past is there was a manufacturer that making them, but they were scary. But we're sort of getting a little bit away from other trends. But that technology is out there.
There is a standard for vanilla and synthetic and all that for mooring ropes. It might be, I don't know if my first fit is. I mean, I know we're splicing. I don't know if we're doing it inside. But I would definitely, especially with the synthetic rope, at least have a look at what the boring standards say, kind of go with that. I've seen them slip because somebody made a way too short of a splice on the boring rope, and luckily we noticed it just before it went. It's like, oh shit, drop the rope. When we dropped it, the splice is actually unraveled. That was during boring operation.
I think you want to have 3 foot lengths of full diameter and then like 3 more.
I think that's not right. But we
But
want 5.
it's actually, they're not,
Synthetic means 5, and that's big ego.
they're not being paid for this advertisement. In independent testing that Alex has done a lot of, he's sent pieces out to see what they were breaking. It seems like the Portland numbers are pretty good to what they advertise, and some of the other manufacturers are not as good. Steel being one of them. So that is kind of an interesting thing that we notice, is that they're not necessarily all the same. I don't know. I find synthetic very scary. I've seen it break, and it's been totally like, bam, you know, like with trawl wire, it's like, you know, like you got some. It seems like you just got that extra second to and die. But, you know, the nice thing with the AM steel is it does not seem to store much energy. So it's like a shocking noise, but it's not gonna like rip like the description of the polypropylene.
I forgot during a demo that some people were involved in, actually. We had our AM steel tied off to our winch, like line on the winch, through a block, tied off to the A-frame bleed. And we A-framed out while we were doing something else during a demonstration on video. Popped the AM steel with the A-frame pulling against the winch, but it didn't. It just literally just fell straight down. It didn't. It allowed pain. We're like, oh, that's why you're training.
Let's get any other questions, comments, no transfer safe stories.
I'm curious if anyone's ever done climb grips under like a really heavy load. I've done it for light stuff. Curious if anyone's done climb grips on like 10,000 plus pounds.
We did this before on a client once. That was just like, we just put the line on, so we could just get a little, we needed just like a little slack. So we could, I don't think, we pulled it like.
Some of that stuff works better under a head. Saying when it slacks, it slips. So
Because like the NSF wants everybody to write these extenuating circumstances plans, right? So what do you do? Start writing it out, look at the safe working modes. Properly sized yellow grip for 322 and for T is actually quite lower than what you might be working. 3x19 yellow grip size doesn't go up to 18,000 pounds in its inspection, but mine does. But does that matter? You know, I'm not really sure.
I mean, I think it depends on what you're getting back, like what your package is, as far as what you're gonna use and how much wire or cable, synthetic, whatever it is you have out. I think that basically it's gonna be, what's your tension, how much line do you have, and then you kind of go from there as far as what's your best recovery method or transfer method. It's gonna vary for all of those components. How much weight, how much wire, what type of wire.
We damaged 681 because the line grip was the wrong size. It was the size smaller than it was supposed to be. So it pinched it and attenuated the fiber, essentially broke the fibers in that spot. And we had to get a whole school, so we don't have that knife. Well, that's good, like, it's so rusty that you can't read the numbers, like, should you even use it? Probably not.
No, you definitely should not. You should throw that away. If you can't read your shackles or your shivs or your blocks or anything on deck and you don't have a diagram, or it's not something that you need a diagram for, but if you can't read what's on what you're using, you should get rid of it and get a new one. Slings, heel grips, guy grips. If you can't figure out what size it is, get rid of them. They're like $3. Just chuck it. So. Which releases? Oh, yeah.
They don't have any like weight ratings or anything.
They're super special. Yeah.
You said Pelican earlier, what is that?
That's the same. It's the release. Yeah. So like that hook that comes in, if you ever can't pop your Pelican hook actually while you're doing a mooring, like say you loaded a lot of weight, you can actually do a tension transfer to a stationary cleat to have your A-frame help you pop that for you and release the Pelican hook. Yeah. I'm not super strong. There's heavy stuff on deck, but you figure out how to use your resources for you, not against you. Lift with your knees, not your back. So.
I personally always clean them because I feel like I
Yeah.
unconsciously like wrap my hand in a bowl.
Yeah, don't wrap up.
What's that other one we have? It's like a C plant.
Yeah, I don't like those.
Well, because what do they call it? What do they call it? Those are designed specifically for that. They're harder to pull.
Yeah.
They're
We
always
use
the
them on the
same.
Remus. I forget what
They're always the same to pull.
yeah.
Retention, so.
I forget the names for the little circle ones, but I know what you're talking about.
We have big circles, so.
I don't use them, but we have them.
Just something else.
It's just like it's like a literal C that's just even and you're seeing them. I think so. Yeah. That's right.
Those are good. You might not like them.
They're good for gliders.
They're higher for all the catch.
So something else that Amber and I noticed when we were putting together this presentation is that really don't have very many pictures of dealing with screw up and load transfer. I think it's kind of interesting that
Well, when you're
It's when you're running the deck. I had a lot of really great demos from this year, actually, of a bunch of different deployments I did across our ships at Scripps, and every slide that I made, I was like, I know the exact image from deployment in my brain that I want to show to the public, and I do not have that image. So if you are setting and forgetting something for like 24-hour ops, just take a little photo. Or like take a photo of the deck, and every now and then you're like, oh wow, thank God, where I tied off this one piece of equipment is noted in this photo. Or, oh, I did put it in this bolt diagram. So just a reminder, if you're on deck, it's okay to take photos. Don't do it mid-deployment. There's always scientists taking photos. Just ask them, hey, can you take a really specific photo for me when I get to the port side of the A-frame, please? And then they won't know what you're doing, but they'll still try. So ask for help anywhere and everywhere on the boats, especially with photography, because it's really hard to share these with you guys when there's not usable images to kind of help you guys see what we're talking about. We're obviously not doing a load transfer or at sea right now. So this is part of our chats where it's awesome to get to meet up and get to see everyone, but you don't always know what everyone's doing. So I think that we should probably end. Okay.
Yeah,
Anyone
almost
else?
there, almost there.
Yeah.
Like relating to that, like, is there a good like repository or place to find like explain code transfers throughout like
I think a lot of that is maybe by institution. I mean, a lot of that is going to be on a cruise by cruise basis, even like scientists upload whatever they're going to be using on that cruise to MFP. That's what I go to look at. That's the diagram I use to talk to them before going to sea. I'll be like, hey, I see this is going on. You want to Zoom and talk about it? Talk through where we're going to do these things, whatever the case may be, before you show up with all this stuff. But as far as how you do it, I mean, that's teching. Everyone does things a little bit differently. We hope that we do it in a similar way and we're not all just jumping off the ship. But I think for certain things to learn, we learn from each other whenever we can go across different vessels and see things, or when I get to work with MarSSAM, or when I get to work with OOI, different cruises, that's when we can teach each other. But it really is the community and just what you can teach yourself when you're at sea. You don't always get a primetime teacher when we're at sea. You are your own teacher, and that's okay. But give yourself some extra time.
And I would just go further with that is look at who's in this room, look at who's in this meeting. Your home institution does not have load transfers, but something that's really a strange thing you're gonna do a one-off. You know, is it like something Lance is doing? Is it like something Farm is doing? Is it like something, you know, Scripps does all the time? Because like we are available. We're a community of people that are our resources, and it's not like Matt's gonna be like, oh, it's proprietary scripts, you know, like. Well,
Email Alex, she can help point you in the right direction, point all you all in the right direction.
Because I know, like, I work with Alex, like, and like, you record deployments, so I like know that, but like, if I'm gonna be in working in other things, there's just different ways to do that. So that's what I was asking.
Sailing lots of different boats. That's why.
Dig into
Oh.
YouTube.
Yeah, that's what I was, like, I didn't know if there was any good channels or anything to.
Let's go find us. It's,
Oh, I was just curious. I'm a tech manager for the Antarctic program, and this is kind of take pictures and yes. And we have like a very robust safety system. So if anything happens on the ship where anything is like remotely near damage or anybody has even gotten hurt enough to get first aid, there's going to be a report written about it, and there are going to be pictures associated with that report. And so we have like years and years of like what went wrong, right? Like just the, and I'm just curious if that's something at every institution, because I would love to share those across teams.
I mean, I think that every ship has their own way to address what goes on, but I mean, at Scripps, we have NCRs anytime that there's something that happens, whether it's crew or science, we have non-compliance reports, and then those get sent out. I mean, I think it's a big push across the fleet right now for cameras all over the vessels, because not all these accidents necessarily happen on deck, but for those specific ones, we're talking about deck-related activities, all of that is recorded, and we go back on the vessel and take the recordings from our cameras, and then those get compiled into our reports. So those are in a database, and people have those things. I don't necessarily think that people share them all that often.
I save all of our canvases on the cameras, and I've got them in a little file that I share with the chief mate, and they'll pick some of them, and they'll show this meeting.
One other thing I want to say is like when you have, like this, for example, like this is much more of a mess up than it kind of looks like in the picture. Because it's got like a triggering cord hanging from it and a piston cord hanging from it. And it's, you need to have a clear chain of command. So don't everybody like freak out and go all like 3 people running around. Like make sure that you have one person who's very clearly in charge, and make sure that, you know, people are in a situation where like it's not a high drama thing. Like, yeah, it sucks, but like, hang there, come up with a plan, figure it out. I walked away with pictures. Yeah, Matt dealt with that, and he did a great job. And he dealt with it totally in a way that I would not have. I would have done something completely different, but the end result was the same. By the way, that wire, I think we sent to a wire pool because you could see through it. So we did a redetermination. I don't know what the result has been.
That's interesting. Barbara pulled it for us. Thank you. And it broke above the breaking strength of the wire, but of course at the kink.
It's been a while since I've seen a wire like held it up. Through strands were had.
I think it's also really important to note for, especially folks who are like just getting into this field, that these are lessons learned and you are not going to get in trouble. And it is really important that we do document these things, we do talk about them, because it'll help us all as a community be better and be safe. So don't ever think that like there's an oops and it's gonna like cause some like, you know, there's, if it's big oops and like somebody dies, like it's a different situation, right? But we need to make sure that we are supporting each other by talking about our oopses.
Absolutely, and I'm glad you said that, you know, this is the place to share the knowledge. You know, I'm not sitting back here and like, oh, I got to check. No. This is the place to air, hey, I had this problem, what did you encounter, how did you fix it? It's a safe place for sharing those shit moments.
I really like how you said when you had that issue, you stopped, got the captain, got the bosun, had a discussion, what do we do? Like you said, it's all hanging under tension. It's sketchy to do some things, but it's just hanging there under tension.
I'm gonna point out, we were in the ice in this case, right? So it was flat, like you're not moving, there wasn't ice bearing down on us. Had we had this situation when we were at sea, I would have insisted that we run the winch down to like 50 meters or something, right? Just get it underwater. Because if it's underwater,
It's your best anchor.
it's just, if anything snaps back or anything weird like that happens. And if you bring back something that is just, imagine, you know, that this was bird's nested for 300 meters and like you can't even see, but you've kind of gotten an idea. That's when you're like, okay, we're gonna just take a time out. We're gonna put it back in the water. We're gonna talk to the captain. We're gonna talk to chief scientist. We're gonna talk to everybody. And you're probably gonna end up calling home and being like, what the hell do we do? You know, like we got $1 million thing down there. We got 100-meter snarl that's like could slip at any moment. What should we do? And come up with a real solid plan and ask them. You know, should we cut the CTD off? You know, like, what do we do? And you know, like
Is it insured?
right. So that's where you have to like we got pretty darn good internet in most places now, so you've got to rely on, you know, your shoreside is there, and shoreside is also like Hawaii might still be open when Hawaii's closed, right? So remember that you can call Hawaii when Hawaii's closed, or you can call Hawaii when Hawaii's like.
Also, all of us answer our phones. Christmas Eve,
emails or
10
whatever,
10
yeah.
at night, like,
That was in the
Yeah.
last 20 months.
So yeah, we should probably wrap up. But thank you guys. I hope this was helpful. Huge shout out to Heather, sorry, Amber.
Heather is our port captain and she's a really awesome lady, so I'll take it.
Amber put this whole thing together. She did amazing, and can't say enough great things about her. So, and I also just want to thank, you know, everybody. I mean, there's pictures from everywhere in here. So, I mean, this is all of you guys. So, thank you very much.